Okay, so it's 2 o'clock Eastern, 2:01 in fact. Clara has joined us. Hello, Clara, welcome.
Hi, everyone.
Oh, wow, hey, you did fix it.
Woohoo, okay, awesome.
Okay, so now for session B, you will have the capability to speak up with a question or comment, and we will hear it here in the room. So that's a great thing. Thank you, Hannah. Workshop session B is all about running TEVA. So I have just a few introductory slides, and then we will run TEVA in the quasi-Jupyter Hub environment. And Abner and or Clara, I'm hoping that those folks who made a request to be admitted to quasi-Jupyter Hub in the last hour or so, you saw those requests, and hopefully everyone will be good to go.
Yeah, I'm gonna go through and check the requests now just to make sure that we didn't miss any.
Thank you so much. Okay. So I just wanted to give you a brief description of the example data set that we have stored in the HydroShare resource. And it came from the paper that y'all read. It's the case where we used high and low DOC target classes as an example. So there are 91 observations of 54 features in that case. And the reason there were 91 observations is that we had to filter all the CAMELS sites from across the continental United States and find those sites that had at least 3 or more observations of DOC. And it happened that there were only 91 sites with that met that condition. So it's kind of a smallish data set, but it was serviceable, it worked. There were 54 attributes, catchment attributes that we used as inputs in this case. And so you see in the diagram on the right, those were the sites that had sufficient numbers of DOC, and using Jenks natural breaks, I classified those into a grouping of low DOC from 0.8 to 4.6 milligrams per liter, as distinguished from those with high DOC, anything over 4.6 milligrams per liter. And it happened that threshold of 4.6 sort of aligned with the domain science as detailed in the paper. I'm not going to be able to remember the details in the moment. So here's an example of our sites with high DOC. They tended to be mostly in the eastern US and aggregated along the geographic clusters of coastal Atlantic and the Great Lakes, upper Mississippi and Ohio valleys and Appalachians. And on the right-hand side is what we call a perceptual diagram of the 4 geographic clusters of sites across the US, and a kind of graphical depiction of the catchment attributes there. Deeper soil depths and evergreen deciduous cover were characterizing those sites that had high DOC. And in contrast, the sites with low DOC tended to be those in the western US, characterized by steep slopes, shallow thickness of overburden materials, and evergreens, and also snow cover. Again, you can read the paper for more details, but that's the data set that we've brought to you today and stored in the HydroShare resource. And we're going to run TEVA and generate some conjunctive clauses and disjunctive normal form clauses for this study domain using that data set. And I just want to talk quickly about, looks like we might be missing a slide. False positives and true positives, true negatives and false negatives. That was detailed in the paper. Hopefully you are familiar with this. We could come back to this in the last 15 minutes of this session if we need to. We'll find that slide that inadvertently got dropped. But just know that depending on your application, you may want to be mapping some of the output that comes from TEVA. And for example, here we can see true positives indicated with solid red dots, true negatives with open gray dots, and then false negatives, open red dots, false positives, solid gray dots. So depending on your application, if you're working with spatial data sets, you can actually illustrate your data as well. Here is where we were to discuss an overview of TEVA outcomes. Ryan is feeling under the weather and can't join us today, but in general, what you're going to look for in the output of TEVA once we run it is a plot that looks like this. And on the x-axis will be class coverage, or what we might call sensitivity. On the y-axis will be positive predictive value, or what we might call precision. And the goal in this work is to get outcomes that are up in the upper right of that plot with greatest fitness values. So they're observations, sets of features associated with a particular outcome class that have high class coverage and also at the same time high precision. And if they do, they're going to be focused in that upper right of the plot. We can, and we have generated some graphics in this tool that helps display conjunctive clauses as square dots and disjunctive clauses as round dots. And you'll see that as we play with the tool. And the order of those clauses will be identified as well with a tool that you can hover over each of the dots. And that's a new development of the tool that with thanks to Ryan and Ali that have developed these post-processing tools. So here is what the view looks like now in the new tool. Coverage again on the x-axis, positive predictive value on the y. CCs indicated with squares, DNFs with circles, and then there's going to be a fitness contour that's shaded. And you'll be able to actually zoom in or out on this diagram using the tool, or using the bokeh package, which is a post-processing of the TEVA output, and hover over any one of these dots to understand what it is comprised of. And so, oh, here's the slide I was looking for. Just a refresher on true positive rate or class coverage. Again, it's the ratio of true positives over the combination of true positives and false negatives. While the positive predictive value or precision is a ratio of true positives over the combination of true positives and false positives in your data set. And this is difficult to grasp at first. Sometimes I go to Wikipedia and I find this diagram and it helps me figure it out. These slides we're going to store to the HydroShare resource after this workshop. So if you want to come back to these slides and kind of sort out true positives, false positives, and class coverage and precision, it'll be there for you. And we can also answer questions in the last 15 minutes of this session. But it'd be more fun just to jump right in and run TEVA. So here we're going to actually leave the slides and go into the HydroShare resource and run Jupyter notebooks that have been prepared by Ali and Ryan. And Ali is going to take over instruction. And using my computer, we're going to share his operations in the HydroShare resource. And so any questions at this point while we break to kind of switch over? And you can speak them out if you would like to, or raise a hand and put something in the chat. Okay, hearing none, we'll dive right in. Ali, go ahead. Do you want me to run that?
Could you share your screen?
Share my screen?
I'd like to share, yeah.
Okay.
So while Kristen is sharing her screen, I want you to open the README file in the HydroShare resource.
Pardon me?
The readme file, do you have that?
I do, right here.
Because I need to do all
So if you
this stuff.
scroll down, you get to the README file, open it up on your computer. Oh, it's gonna tell me that you downloaded it, so I'm gonna go.
I think running the tool was more exciting.
So the first page in this README file is simply how you were to gain access to the quasi Jupyter Hub computing environment. Now that you've gotten there, you wanna click on here?
Yeah, so in the README file, there's a section named Set Up Your Environment, and there's a link there that I want you to open it. It's a link to a GitHub page that has the instruction on what to do next when you open the HyperShare.
Are we sharing this?
I think,
Probably not.
so it would be good to share that as well.
You can see the little red share. It's way up there now.
So share that one. I think that's the one.
Yes.
Yeah. And just. Okay,
It's sharing, you're just not in the,
yeah,
Well, this we know isn't gonna work. We're just hoping you guys can see what Kristen's doing on her screen if you're in Zoom.
I see a GitHub page.
Okay, good.
So there should be a GitHub page that you're on.
yeah, I can take
Yeah,
It's gonna kick you out.
sorry.
that's good, that's a good thing.
Okay. So in the GitHub page, there are instructions on what to do to install. Okay. So everybody is seeing the GitHub page. And while you're looking at that, I want you to follow the instructions in the README file that shows you how to open quasi Jupyter Hub. I guess you already did that.
Yes.
So if you go there, let me open that myself as well, I think. Do you know why it's not working?
You see the kernel up there, I think. Environment, I don't know, I haven't done it.
So it's not working when you try to open it.
Yeah,
It may be needing to be refreshed if you go up to the HydroShare. And it may be open.
are you?
Yes.
I think it's the wrong thing. You don't wanna copy it, right?
It looks like a bunch of the buttons are overlapping with each other.
Yeah. You can resize the window somehow.
Yeah,
I
that's
think you
already
should-
done there.
I think you should resize your window. Because they're screwed up buttons.
Okay. Oh, right. So more in there.
So now the
Move
open
your-
with should
move
work.
forward, move the Zoom thing. I don't know,
Just a little.
so you can reach the open with. There you go.
Okay, thank you. So you're seeing the HyperShare webpage, right? I'm gonna open this one. And well, you have to agree.
You can just agree to the terms of use, yeah.
Thank you, Clara.
There's nothing nefarious in them. It just says don't mine Bitcoin with our compute services.
Okay, so here you already did this, and just move this So that my server, and then should take mine. Okay, so from here, you can follow just the instructions on the GitHub where you open the terminal and do step-by-step creating the environment and then installing the I kernel to be able to run TEVA. Yeah, I think the details instruction is there, but yeah,
The instructions are beautiful. I just didn't
yeah,
have
they
time
are
to get
pretty
there.
detailed and yeah. Please go ahead and follow those instructions for installing, for creating the environment for TEVA and installing the kernel. And let me know if anything goes wrong. No idea how that.
There's people smiling and nodding heads in here, so that's a good sign.
That's good, yeah.
It's actually pretty incredible that we can host this workshop across the continental United States in real time. Thank you to COVID.
Clara and
Thank you
Abner.
to COVID, Clara, and Abner.
Yeah, I mean, our compute team tries to make sure that this is continuously available.
It's awesome.
Yeah.
Oh, and Abner said, feel free to send me a direct message if there are issues setting up the environment with Quasi Jupyter
Okay.
Hub.
Thank you so much.
Zoom so I can see what you were saying.
Abner set up
Yeah.
the instructions and stuff for the
Yes, there's
environment.
one small step
Yeah.
that you need to take. What are you seeing in Zoom? Could you see what? Okay, your screen is not shared. Yeah, it's weird. Mine is not shared. Oh, we need to do something here.
I don't know, we should. Hannah.
Okay, how about now?
So I just.
Are you seeing the,
You can copy and paste it. Okay, and then just recopy that.
are you seeing in the Zoom the Jupyter Hub?
I think it may be because you're splitting the screen.
No, it's, if you're seeing this.
No, we see.
We're not worried about what's up here.
We see like.
We're
I
not
see,
worried about what's up.
I see the server is starting up and the bar loading.
Okay, good.
And I did have to refresh my page when because I was on that for like 5 minutes.
Yeah.
And then if you refresh. sometimes
Refresh
it'll
it
load
does.
over.
Space in there.
Faster.
We're gonna have to go.
So what I wanted them to see is if they can see your screen shared.
Yeah, you wanna see the computer.
See this?
And then hit enter.
Yeah.
Enter.
We're seeing.
Yeah, they're seeing the screen
And then
Okay,
it's
that's good.
going to.
That's a good sign.
Yeah. because you have Python on your laptop probably. In different environments, maybe.
Yes, that's why I hate switching computers.
Yeah.
You
It's
know how it
almost better
works
if you've
online,
never
yeah,
installed
exactly.
Python on your computer.
So you already done this step, I think, and your server is up and running. Again, you can go ahead and follow the instructions. I have to do the same thing here. To install TEVA.
And the reason that we're going through these steps is that TEVA relies on certain package dependencies. And so Abner was kind enough to draw up a YAML file for us, which is helping the computing environment know what dependencies it needs and linking them to that. The other tiny piece of information is that TEVA right now runs on a certain version of Python. And so this YAML file is directing the computing to refer to that particular version of Python.
Yeah, so you can set up virtual environments kind of whatever suits your needs in Quasi's compute services. And if you want them to persist between sessions, they can also do that.
So
Oh.
Excellent.
It's
I was just asking that question. so-
She said that
Oh.
much better than I did.
Yes, if you one thing I will mention, I don't know if Abner brought this up, it is if you are done at the end of this session, one kind of like best practice when using online compute resources is after you're done, you go to File, Hub Control Panel, and stop your server. That way the server doesn't like run continuously in the background. But you should be able to have your environments persist between sessions, and you have persistent storage in your environment. So if you like generate some output during this session, it will still be saved in your Jupyter Hub environment next time you come back to it, even if you start a completely new session. It's not like a ton of storage by any means. It's not like 20 gigs like it is in HydroShare, but it should be like 9 or 10 gigs, I think is what it is.
Cool. We did add a slide, Clara, to the end of the workshop that reminds people to stop their environments, and we're going to ask you to help them walk through that.
Because we forgot.
Yeah, we all.
Yeah, that sounds good. I'll demonstrate at the end of the
That'd be cool.
Okay. What we're seeing is on the screen is me installing the packages needed for TEVA from the environment. And then we're gonna create the environment, activate the environment, and install the Jupyter kernel. You guys all successfully installed.
I see a question from Scott Hamshaw. Is TEVA on GitHub? Or also, it is not at the present time, but we anticipate doing so. We have a couple of improvements to TEVA that are being made, and then we will post it to GitHub and make it more widely available beyond just this HydroShare resource.
For those of you who are a little more familiar with parts of TEVA, there was a important component of it called sensitivity that the version we paid for didn't port over. So we fixed that. So we just didn't want to change things within a day or two of the workshop.
If you install it, please wait for me to finish this process as well before running the code, because there's one small thing that you need to change the kernel to TEVA workshop before running the Python code, and that's pretty important.
So install the kernel and stuff.
Yeah, install the kernel. Yeah, follow the instructions on the GitHub page, and then we can move forward from there. Oh, actually, that's step as well. Let me get GitHub page. Okay.
The first notebook you're going to want is the initial one.
Yes.
Yeah.
Yeah.
That's one. Yeah. We'll go over how to change the kernel. Oh, cool. Thank you so much.
Oh, so you should not say.
That's a great question, Scott. Donna just stepped out to get a cookie, but Scott Hamshaw is wondering, any comments on using TEVA with extremely unbalanced classes, like 3 classes
See these 2 lines?
total, 2 have hundreds of samples, but a 3rd class might just have a couple of samples or observations. Yeah.
So it was designed for extremely unbalanced data sets. However, with that caveat, like think of Chagas disease,
Right,
the thing you're looking for is definitely in the minority. And that's going to be the case for most data sets. But you still need a
sizable number,
sizable number of whatever that minority is.
right?
You could certainly try it. I don't know that we tried it with that extreme a case, but
Yeah,
Yeah, I agree, Donna. With only a couple in one category, I mean, it will work, but
Yeah.
how believable those are is just hard to say, given not enough to develop a true pattern.
right. Well, she just got really lucky in the few that you had as examples were exactly what was in your testing data set or, you know. Yeah.
Is it done?
okay.
It's going. Okay.
So it looks like most people maybe have gotten things installed or environments set up.
Yeah, okay.
Thumbs up in
Thumbs up in the room here.
What about online?
Online, are there folks that still need a few minutes? Just type into the chat or,
Yeah, there's plenty of time if they want. Jesus is installed.
It's just installing the. You can start actually.
Okay.
I had a look at it.
How about people online?
we're not seeing any notes from folks needing more time, so I think we can go right ahead.
So
Or they left.
can you all see my screen with Jupyter Notebook TEVA model run open? Okay, so what I want you to not forget is to change this Python kernel to TEVA workshop environment. And let's try this one. And let's try run the first cell. Okay, it's working.
Can you, I'll explain briefly, I think there may be some participants who've not used a notebook before. How did you activate that cell to run it?
Just hit enter and shift.
Enter and shift
Yeah,
at the same time.
yeah, or you can use the button on the top, the run button here. And that would run the cell that you are using, yeah.
Okay.
So everybody ran that cell and
I got an
successfully.
error.
What's the error?
It says that there's no module named TEVA, so which did I mess up?
You have to choose the kernel
Yeah,
last year.
I am in the, yeah, just in the kernel.
Okay.
Go back, you here.
Then
That's good, because if it happened here, I'm sure it happened to somebody online.
Oh, yes.
But it worked for the others, right?
Oh, okay.
So we're trying to
Yeah.
activate TEVA workshop and then rerun that command.
Yeah, so if
I'm
you go
so
to the
sorry.
readme file,
Okay, here,
Do that.
oh, like copy this?
Yeah.
Do I keep the $sign or no? No. Okay, let's see, so run that, and
Okay.
then
And then rerun this command, does she need to delete?
this one. This again? That again.
you can
No,
just do up arrow.
Oh, okay. Sorry.
Thank you,
One,
Sharon.
two,
This one. Okay.
no.
No.
I'm adding those notes in
Go
to the chat.
more.
Or not
I
that bit,
think
sorry.
this is the one that you
This
want.
bit, okay.
What chat are we on?
We are on the Zoom chat.
No.
And then come
Close
back
that
over.
one.
Not the Teams chat, we're on
And
the
open
Zoom
it
chat.
again.
But that'd be lost to me.
Okay.
Now.
No, we're
okay,
gonna
we're
download
gonna
the chat.
say-
Okay, so let's.
Couple of people in this room got an error when they ran the first cell of the notebook, so we're just
Here we
troubleshooting
go.
that.
Right.
Anyone else had an error, just,
No,
just
like I ran it, there's no error,
but
should I say something?
No, it's perfect.
Okay.
It would give you an error about TEVA saying the module didn't exist.
Okay, okay, thank you.
Actually,
So we either had
never mind.
people who ran it, got an error,
So that works.
or we had people who ran it perfectly, and because it didn't say anything, they don't know that it ran perfectly.
Downloading still.
But those are the two extremes.
You can go ahead.
Yep.
Let's go to the next step. And then you can go to the next cell. It's basically just reading the data file that we have as the input file and extract the input feature list from the pandas data frame it has. and a bunch of other lines of code that we basically, what we're doing is just extracting the data from the, with the line of classifications, we're just extracting the input features to a NumPy array. And then in the next line, we're extracting the, I'm sorry, it's vice versa. Actually. We're extracting target variable to a NumPy array with the classifications line variable. And then in the next line, we're extracting the input features into a NumPy array. And then a bunch of other things that are basically just saying, oh, what is the shape of the data set and other variables for TEVA. You can again hit run and see if it can successfully read the data into the notebook.
This is where he holds his breath.
Okay.
Everyone in the room works for them?
Look at my generations.
Okay, so now we can run TEVA. If you didn't get any error reading the data, you can go ahead and run TEVA by simply running that cell. And also I'm sharing my screen if you're not sure what to do. But don't export the files, don't run the next cell for now. Let's just run TEVA. If you're getting any error online? No? Okay.
Just pop a note in the chat if you've had any errors, but looks like it's running.
Just keep watching. It's doing it. I was just like a general type of question, like, is there a progress bar that tells you how long?
No, it doesn't. It doesn't have that, but it's possible.
I mean, there are so many
Oh, okay.
parameters to
Oh, never mind.
20 plus.
Yeah, so there are iterations that you can see. So the first part is the
Like Donna
CC
was
part,
saying
and
that
now
we,
it's doing
first
the
we would
DNF
recommend
part.
we use the default
Remember,
settings.
there were two parts of this.
Yeah,
And now it needs to do
different,
60.
different for every other data set, like these parameters, we have to
No, it's
choose
It's
them or
doing
we
it for
does.
low and then it'll do it for
A lot
high.
of the
Yeah,
data
I
sets,
think
we
so.
will try to bunch of them, we can run them with these
the same ones.
parameters here.
Okay.
There are a couple you might want to explore changing, but
I mean, some might need tuning
thank
for.
you, all thanks to
Oh,
John.
that's what's- I was like, why is it running?
We did a lot of people already.
So if there were even more like groups for that probably.
So you can apply schema to.
Yeah.
Does the generations have to do with the input data, like the feature classes and stuff, or does it have to just do with the algorithm? Does that make sense or no?
It's not dependent on your input, it's just how many generations you want to create
Uh-huh,
of those potential solutions.
okay, and
So
so
it's
that's
like how
something
long you
you
want to
could-
train.
Okay,
You have like 30
It's like a
books.
hyperparameter. Okay, so how are we? Is it running?
Everyone's run. Can we move on to the next?
I think they're
So?
still running, but while you're waiting for the run to finish, the next cell is basically just exporting the results, the outputs of TEVA into Excel files. So we have CCs and DNFs, and you already know what those are. And this line, you don't have to run it because we already uploaded two output files for you in case your algorithm didn't work. So you can use those files. But you can go ahead after you finish, after the run is finished, you can go ahead and run the plot cell where you can see output plots of TEVA, which is nothing like what Kristen showed.
It's way better.
Although for those of you, like, this is all I know, you work in R or a different language
Yeah.
and really want to use this,
Mhm.
Krista and I learned with just having the Excel spreadsheets. So at some point, if someone really wants to get into that, you can look at those and then the data's there.
Yeah,
So you can look at the data or however you want to with a language that you're more familiar with. But I really do love what Ryan and
Yeah.
Ollie put together to
So-
at least post-process it if you're in Python here, so.
Yeah. Ryan actually put some slides together to show what the actual raw output looks
I love
like.
that, because if you're
Yeah.
familiar or good in another language, you would want to have that kind of control.
Yeah. So.
Okay.
Mine is done. If can anybody test it to see if they can get some output plots? Okay. So you can see the output plot looks nothing like what Kristen just showed you with the fitness line and pretty dots and everything. But that's what we are gonna do in the next session. So stay here with us for the next session and we're gonna have some very beautiful plots that Ryan generated. And yeah, so I think if there's no error online, then we successfully run TEVA.
Yeah.
Excellent.
That's just the start, right?
Questions? Yes, Jess?
Using this kind of like platform, where do the exports go? Like, does it just go onto the online or does it actually go to your computer?
Well, I guess for running it on the cloud, I think we can ask Clara where it goes. But if you aren't running on your local machine, it definitely goes to the same directory your code is on. Yeah.
Okay.
Or you can.
Sorry, what was the question?
Sorry, I was just wondering, like, running this on the cloud, where does, if we were exporting the files, where do they go?
So if you can either save the files to the content tree here that you see on the left,
Okay.
and you can like just put a save as function in your code and it'll save it to that file output. But if you're just generally downloading something, it's going to go to your local machine downloads.
Thank you.
But in this code, we are not saving them, so I think it's just stay on the screen.
Well, and one other subtlety here is that this TEVA is a non-deterministic method. So unless we had set seed initially, we each will get slightly different output. And so because we wanted to work with the same output in the next session, C, for this workshop, we created output files that we're going to work with in session C. But just know that if you run this 5 times, you'll get 5 slightly different answers. They should be very similar. For example, the output might show a slightly different range of values for certain features, that kind of thing.
Maybe in decimal places.
Yeah.
So I, to be safe, usually run it a couple of times because I like to see that I'm getting very similar solutions.
Yeah.
Regardless of what the initial seed might be.
And something
And if you're not, that's one of the parameters you want to change and let it run longer. Because you're never guaranteed with an optimization program like this that you are finding the actual minimum or maximum. You're getting something that's in hopefully a good space, but that's only if you let it run long enough. So.
And when you say run long enough, do you mean the generations?
Yeah.
Okay.
And just before we finish this session and go for another break, I want you to notice that we have 2 plots here, one associated with high outcome and one associated with low outcome, which, yeah. If you had 3 output classes, you would have 3 plots.
Excellent.
Okay. Yeah,
Alexander?
in the slides, there was fitness contours overlay, and well, I'm not seeing those here, which is one thing, but I was also just curious what that fitness function actually is. Is it a combination of specificity and?
We're gonna actually, in session C, we're gonna take the output from TEVA and post-process it in another Jupyter notebook where you will see those fitness bands displayed.
Yes is the short answer to your question.
Okay.
And that's one of the reasons maybe we'll give them the earlier paper as well, if you actually want to see what the fitness function looks like.
The Hanley paper?
Yeah.
Yeah, we could actually upload the Hanley 2020 paper to this HydroShare resource, so you'll have it.
Because as John says, it's called a hypergeometric fitness function of fitness. And I thought it was a brilliant idea of John's when he took the evolutionary algorithm class to use that as a fitness function. And as he said, and I'm pretty familiar with statistics, but I hadn't seen that used. It's been around for 100 years. It's such a powerful statistical approach. And I just thought it was brilliant that he decided to use it as a fitness function, which if any of you take an evolutionary algorithm class, the key is defining your fitness function or your objective function.
So what are we seeing in these dots?
We'll get to that in the next session.
Right now, these are the default plots that
Yeah.
come out of TEVA, but Ryan and Ali have generated some post-processing tools that take that to another level.
So if you just ran it, this is what you'd get. And one of the things we could have done in one of these sessions was just show you how those Excel spreadsheets are corresponding to each one of these dots, but they made a nice interactive tool to help you with that. So I think if we go through that first, then this would make more sense.
I mean, just like visibly it says CC order 1 to 8,
Mhm.
DNF 1 to 12.
Exactly.
Next session.
Yeah, next session, we're gonna have an interactive plot dashboard that you can hover over each of these points and see, oh, this DNF is consisting of these 5 CCs, and that's a order 5 DNF. And we'll talk about the meaning of these.
So you can show which feature was important.
Yes, not explicitly, that's a update in the future, but we can see what features are constructing each of these CCs, and then what CCs are constructing each of
The DNF.
the DNFs.
And that's what, again, if you're familiar with a different language that you would want to post-process this in, you might feel more comfortable just analyzing the raw data yourself. But I think it would help you to do that, to look at these interactive tools, because they took a stab at what how they might want to start to look at this data. Because you've got a lot of things that you want to search for in these solutions. One is it's a different terminology if you take an evolutionary algorithm class. You usually want your fitness to be very high. In this particular case, we're looking for a fitness value that's extremely low. It's a minimization problem. But regardless, you want the solution to have a very low fitness, and you'd like these CCs and these DNFs to be the lower order ones. So you're looking for solutions on that plot that are in this upper corner. Yeah.
I think you mentioned it and I missed it. What is the fitness function that's?
It's called a hypergeometric fitness function. You can just Google it right now. I mean, John didn't invent it. It's been around, as he said, for a long, long time.
Just don't close these.
Oh yeah, don't
close
destroy
We're gonna
anything.
run 2 more together notebooks in the next session.